Here, stratified random sampling. It is the procedure of the stratified random sampling. It's the definition of the stratified random sampling and notations and terminology of the stratified random sampling and properties of the stratified random sampling, allocations of the sample size and a comparison of the stratified random sampling with the simple random sampling without stratifications and advantages and disadvantages of demerits of the stratified sampling. That things we will discuss today class. Now here, if we discuss that is a procedure of the stratified sampling, it is divided. Population is the total size is a capital N. That number of units we divide into the K strata. K groups I will divide. In that K groups, it is a ith strata means ith Ni. Ni is called as a I elements are the up to K. It means that the small groups are the stratified are the K groups I will divide. And strata are the constraint such that they are the non-overlapping of the homogeneous respected to the characteristics under the study such that it is a summation I equal to 1 to K, Ni equal to capital N. Draw the sample of the size Ni for the from ith I equal to 1 to so on K. Nik is stemming using that is a SRS, preferable by the WR independent from the each stadium. It is a simple random sampling how we will be the preferred, but the same way it is a when we divide into the status, after that each individual status we can apply that is a simple random sampling with the same procedure, preferably with the random sampling. It is a stratified random sampling procedures. The sampling units of the drawn that is the E system. It is how many units we can take means N equal to summation I equal to 1 to K. Ni units we can be do it. That is called as the construction of the stratified sampling sizes. Next definitions it comes to that it is a whenever we have there is a total large sample of the data. The data is we will be divided into the some groups so that each group is called as the strata. That strata is the summation Ni I equal to 1 to K, Ni equal to N. Such kind of N1, N2, so on, N groups, Nk groups I am taking. That is a total, if we added the total samples, we can get that is a total stratified random sampling. Now, next is coming to that, it is a notational form is a capital N equal to summation I equal to K, Ni. It is a sampling, it is a total sampling. If I take that is a capital N is the strata. That from the strata we can give that is a one of the group of the data. It is a when we divided the small strata, that small strata having that is a small number of objects, number of observations. That small number of observations so we can apply for that is a same simple procedure of the sampling. So that is the small n I can take. That small n equal to summation I equal to 1 to K Ni. That is the total sample size of the all the strata. That is the each one I will take. It is comes to the total means all it with the N1 plus N2 plus 1. If I add it, I can get that is the total values. Next, J equal to 1 to so on Ni and I equal to 1 to so on K be the value of the jth unit in the jth stratum. So it is a population mean of the ith stratum is a yn bar equal to 1 by n equal to summation j equal to 1 to ni and yij. So population mean is equal to summation yij by n. So it is we can get that is a summation means some coefficient is a pj. That pj is clearly capital ni by n. That is come to the weight of the ith strata. Next, the population mean of the square of the ith strata is the si square equal to 1 by ni minus 1. It is a summation I equal to 1 to Ni, it is a Yij minus Y bar Ni whole square. So that is a variance formula. It is called as a population of the mean square. So I can calculate a summation Yij minus Y bar Ni whole square by Ni minus 1. It is a Yij is called the value of the jth sampled unit from the ith strata, and Yij is called as a N1 equal to it is the mean square of mean of the sample selected from the ith strata, and the mean square of ith strata is the si square. But there is a one strata. Then it is a simplifying that is a number of the strata. It is called as the two estimations. If I take that is a summation I equal to 1 to K Ni into yn bar by n. So that it is a yst equal to 1 by n into summation ni yn bar. So like it is a we can go for the latter being the weighted mean of the strata. The sample means it is the weights being the equal to the strata sizes. So that is the n1 by capital N equal to capital N by n. That implies n1 by capital Ni equal to how much n by capital N. So constants are the ni equal to c into capital ni. So that it is a groups how we will be divided, and that is each group is called the status. Status means how we can mean squares, how we can be identify, and mean of the mean how I will be identify that given the stata. It is how many observations we have. That things we can be learned from here. Next, it is the properties of the stratified random sampling. It is a YST bar is the unbiased estimation of the population mean. That is the YN capital N bar. So that estimation of the YST bar equal to YN bar. So since that is a sample in each of the stratum is a simple random sample, we have that is a capital E of YN bar equal to YN bar. So E of YST bar equal to 1 by N into summation I equal to 1 to K, Ni into E in E capital E of Yn bar. So that summation I equal to 1 to K, capital Ni into Ni bar equal to Yn bar. So capital E of YST bar equal to Yn bar. So it is a theorem where variance of the YST bar equal to 1 by N square into summation I equal to 1 to K, and Ni into capital Ni minus N bar N1 Ni into small Ni into Si square by Ni. So that summation of I equal to K, and Pi square by 1 by N1 minus 1 by Ni Sij whole square. In that proof, if I take variance of Y bar St equal to 1 by Ni minus 1 by Ni into Si square. Variance of Y bar St equal to variance of the summation Pi into Y Ni bar. So summation of the Pi square into variance of the Ni bar. So that variance of the YST bar equal to summation I equal to 1 to K, and Pi into 1 by N1 minus 1 by Ni into Si square. Variance of a YST bar equal to 1 by N square into summation Ni into Ni minus Ni into Si square by Ni. So variance of a YST bar equal depends on the Si square. The heterogeneity within the strata, thus that is a small sample or depends on the sample sizes. If the strata have the homogeneous, them stratified the sampling providers, estimating with the generator of the precision. Allocation of the sample sizes, if it comes to the proportional allocation and optimal allocation. So proportional allocation means N1 by capital N1 equal to N2 by capital N2 and N3 by capital N3. That all are the equal. So it is a NK by NK. It is a total is a ratio. It comes to the C. It is a ratio. It is a constant ratio deviations. I will take it is called as a proportional allocation. So if you first one, if I take N1 by capital N1 equal to C, and that is the capital N by small n by capital N, so that N is directly proportional to the capital N. So variance, if I allocation at that time, variance if I apply, variance of the YST bar equal to proportional equal to 1 by N capital N square summation Ni into capital Ni minus Ni. So into Si square by Ni. Next, it is a summation of Ni by N square into Ni minus Ni by Ni small Ni minus 1 into Si square. So it is a Pi by N into capital N minus N minus 1 into Si square. So variance of YST bar is a proportional equal to 1 by N minus 1 by capital N into summation I equal to 1 to N Pi into Si square. Next, the second category, it comes to the optimal allocation, is comes to the Newman's optimal allocations we have. So that this method is selected for the observations for the each group. In the individual groups, it is the ratio previously is the same. So that is a proportional, we have taken that. The proportional method applied and proportional variances I calculated. When it comes to the optimal allocations, at the time, Newman's optimal allocations is that each group individual we should be calculated and total variances we should be added. Then we can, cost will be the minimum. That is called as the optimal allocation method. Proportional method is the number of observations is selected from the each group is entirely depends on the stratified. Then it is using this numerical observations remain the sample fraction is also taken from the constant. So it may be the observations of the Newmans. So it gives the Newmans means it is comes to the optimal allocation method. That is, which means each fraction, it is a smaller factor also we will be considering the optimal allocation. That is the advantages of this allocation, optimal allocation. Next, cost function we can consider C equal to A plus summation I equal to 1 to K, Ci Ni. So it is a where A is the overhead cost and Ci is the cost per the unit in the ith stratum. And the theorem, if I consider that it is a variance of the YST bar is the minimum of the fixed total size of the sample N if the Ni is directly proportional to Ni into Si. So variance of the stratified random sample is given by the variance of the YST bar equal to 1 by N square into summation Ni into Ni minus Ni into Si square by Ni. So that 1 by N square into summation Ni into Ni minus Ni whole square minus 1 into Si square. Variance of the YST bar equal to 1 by N square into summation Ni into capital Ni by Ni N1 Ni minus 1 into Si square. So N1 into so on Nk be the number of observations selected from each stratum of the population such that it is a summation I equal to 1 to k, ni equal to n. This is the equivalent to the minimization. So that is a pi equal to variance of yst bar plus lambda into summation I equal to 1 to k ni minus n1. It is a Lagrange's multipliers method. If I apply, first derivative is equal to the 0 with respect to ni. It is a second also I can take. So it is a second is greater than 0, it comes to the minimum. Second derivative comes to greater than 0, it comes to the minimum. So that is the first derivative I am calculating. First derivative equal to the 0, I can get that is where it will be the minimum that I can be identifying. So that it is a pi equal to 1 by n square into summation ni into ni minus 1 into si square. This is from the variance of the st bar, that is the above we have taken. Further, it is a different kind of the observations of the strata. Variance I got it. That is I added to the lambda into summation I equal to 1 to ni minus n. So differentiation n bar if I take, that is I can get that is the 1 by ni minus 1 by n square into summation I equal to 1 to k ni into capital ni by ni square into si square plus lambda into summation I equal to 1 to k into 1 minus 0 equal to 0. So that it is lambda only. So I can get that is a lambda value. Lambda value, if I substitute into the ni square, I can get that is the ni. Ni equal to capital ni minus si by ni into capital into root lambda. Now it is a summation I equal to 1 to k, ni equal to 1 by n into root lambda into summation I equal to 1 to k, ni into si. So n equal to 1 by n into capital into root lambda summation I equal to 1 to k, ni into si. So root lambda equal to 1 by capital into n summation I equal to 1 to k, ni into si. So n and lambda are the constant. Root lambda is the value of 2. So we get ni equal to ni into si. So a capital into 1 by ni. Capital N into summation ni si. So ni equal to capital N into capital ni si. Summation I equal to 1 to k ni si. This is the optimal allocation for the fixed total sample size. Fixed for total sample size. Next, variance of the stratified random sampling under the optimal allocation. If I identify, that is clearly we can identify. We know that it is the variance of the yst bar equal to 1 by n square into summation ni into capital Ni minus small ni si square by ni. So 1 by n square into summation ni into capital Ni by ni minus 1 into si square. So ni I can get that by using the n into capital Ni si by summation ni into si. This is clearly optimal allocation. So again I will substitute that is the optimal allocation value. Then I will go for that is a substitutional and common terms and up to n groups of the strata. So here I can get the simplifications. Capital N by n into capital Ni si by summation ni into si minus 1 into si square. So here, if I go for the simplification, it is a 1 by n square summation I equal to 1 to n k ni into summation ni si by n si minus 1 si square. So 1 by n into capital N square equal to summation ni into summation ni si minus ni si by si into si square. So 1 by n into s square and capital N square ni si equal to summation ni si minus n si. So 1 by n into n capital N square equal to summation ni si whole square minus n into summation ni si. So like that we can get that is the value of the simplification. It is the variance is the summation 1 by n into summation pi si whole square minus 1 by n into summation pi si. This is a oral idea about it when it comes to the optimal allocation. This is a optimal allocation means Newman's formula. Newman's formula means it is a even the small fraction also we should be considered. Next it is if I take the one problem. 100 employees is to be the drawn from the population. It is consisting of the 500 belonging to two colleges A and B. Mean and standardizations of their monthly wages are given below. Draw the samples using the proportional and Newman's allocation techniques. It is both the techniques that we are applying here. It is the most important. Next, it is that the consideration of the college A and B represent the two different status. Then the population is drawn a stratified random sample of the size 100. So using these techniques, the proportional allocation I am taking here 300, 200, 25, 25 and 5 by into 100. So NISI if I calculate, what happened 300 into 5? So 1500. Then 200 into 10. So 200. So total is how much? Is out of total 500 employees, it is NISI equal to 3500. Proportional, see if it is a NI equal to capital N by capital N. So N equal to how much? 300 by 500. So here first one is over. 300 500. Capital N equal to 300 500 into 300 equal to how much it is? 180. Next N2 also I can calculate 300 by 500 into 200. So that capital N2 also I can get 120. So numeracy, this is comes to the sizes, random sample sizes for the colleges A and B are the 200 and 120 we are getting. This is a capital Ni and small Ni values. Next, it is a Ni equal to one optimal allocation formula is a Ni equal to N into capital Ni Si by it is a summation I equal to capital Ni Si. So that value, if I substitute 300 into 1500 by 3500, that value is equal to the how much? It is clearly 128. It is 129. N2 equal to how much? 300 into 2000 divided by 3500. So it is a 171. This is a values of the Newmans and proportional. Proportional is up to here only. Up to here 180 and 120 I got it. And after Newmans, if I apply, it is a first one is a 170, 129, and the second one is I got it 171. 171. This is a differences between the N1 and the N2. So proportional allocations, it takes that is a starting is a bigger group and is a smaller group, and second it goes to the smaller and bigger group. Like it is a depends on that observations and Newmans. Newmans is the exactness we can get it and compared to the proportional allocation. Next, comparison of the stratified random sampling with the random sampling without a stratification, so that it is a variance of the proportional random optimal random variance of the optimal random sampling, and it comes to the proportional random sampling of the variance. It compares with the optimal is always is less. It is a minimal value less than or equal to variance of proportional. It is less than or equal to original variances of the random variances. So that is a without replacement. If I observe variance of without replacement, if I observe the sample of the variance is given by the variance of y s y n of r equal to capital N minus n by n into small n into s square. So stratified random sampling of the proportional allocation is the variance of y s the bar equal to proportional equal to capital N minus small n by n summation I equal to k and pi s I square. Optimal allocation if I take variance of the y s the bar optimal equal to 1 by n into summation I equal to 1 to k pi s I whole square minus 1 by n into summation I equal to 1 to k pi s I square. S square equal to 1 by capital N minus 1 equal to summation I equal to 1 to k summation j equal to 1 to ni and yij minus yn bar whole square. Si square equal to 1 by ni minus 1 equal to summation j equal to 1 to ni yij minus yi bar whole square. So s square equal to 1 by capital N minus 1 into summation I equal to 1 to k summation j equal to 1 to ni yij minus yn bar whole square. What that is a simplification 1 by capital N minus 1 summation yij minus yi plus by ni minus yn bar whole square. So it is a separation of that simplification summation yij minus yn whole square plus summation I equal to 1 to k summation j equal to ni yij minus yn bar whole square. Just 2 times of summation I equal to 1 to k. Here yij minus yni the summation j equal to 1 to ni into ni minus yn bar. It is a capital N minus 1 into s square equal to summation I equal to 1 to k ni minus 1 into si whole square plus summation I equal to 1 to k ni minus yn bar whole square. Now it is a product of the terms is vanishes since it is a summation ni minus yn bar is being the algebraic sum of the deviations from the mean is 0. If we assume that it is a ni and the consequences of capital N are the large, so that we can take that capital N minus 1 equal to n and capital N minus 1 equal to the ni, then we get that as a capital Nis square equal to summation Nis square plus summation I equal to 1 to k ni into yi minus yn bar whole square. So sum that it is a s square meaning variance I can get. Variance equal to how much? Summation fp1 into si square summation pi into ni minus yn bar whole square. Multiplying capital N minus n by small n by capital N is a both side. If it is a clearly variance of yn bar r is equal to yn by r proportion plus something. So it is a yn is clearly subtraction if I take it is clearly positive. Therefore it is greater than or equal to 0. So that variance of yn bar r is greater than or equal to variance of yn bar into proportion. So that it is clearly conclusion is a holds. Next it is conclusion of it is a proportion of the proportion variance and optimal variance if we subtraction if I observe. it is automatically, it is also clearly greater than or equal to 0. So that proportion is greater than or equal to variance of optimal. So that from the above relations, it is the optimal is less than or equal to proportion is less than or equal to R. This is overall information about that. It's the most important theorem. Advantages and demerits of the stratified. Advantages is clearly it is a data of the known precision may be the required for the certain parts of the population. This can be the accomplished with the more careful investigation to the fused data. Next, second, if we come to the sampling problems may differ in different parts of the population. It is the hospitals, hotels, and prisons and living houses that they can be discussed. And the third one is comes to the administration conveniences can be the expressed. It is the stratified sampling is a more big beneficial. That is the work nature. It is a field work. Such kind of the cases. It's the surveys or such cases. It's the most useful. And the fourth benefit is comes to the it is a cross section population can be obtained by using the stratified sampling. It may be the possible to simple random sampling with the some of the large part of the population maybe they remain repeated things we can be observed. That is comes to the it is a desired degree of the representation of the special case of the population is also possible. Next benefit is comes to the substantial gain is the efficiency is achieved if the data are formulated intelligently. In the next is the skewed population and use the stratification is of importance is the since the large weight may have to be given for the few extremely large units such as the turns that reduces the sampling variability. When the estimates are the required not only for the population but also for the subpopulations, then the stratified sampling is helpful. When the sampling frame for the subpopulations is more easily available than the sampling frame for the whole population. Next, its benefit is comes to its population is a large, then it is convenient to do the sample separately from the strata rather than the entire population. The population is the mean the population total can be estimated with higher precisions by the suitable provided the weights to be the estimates obtained from the each strata. And the demerits of the strata is it may be the contain the error due to the subjective conditions and low efficiency also we have for the when it is properly determined in the stratified differences of the stumps cases it is a we may get that is a lower efficiency. These are two other demerits of the stratified sampling. The exercises these are the things we have so that problem also I explained. This is overall information so we can be learn model examples. Next class I will discuss at the systematic sampling. Here in this class I explained the total concept of this one. Here advantages and demerits of the stratification and stratified random sampling in this case. Here we have to discuss that these are the things. Procedure of the stratified sampling and the definition of the stratified random sampling. Notations and terminology I discussed. I explained clearly. And the properties of the stratified random sampling I explained. Theorem I explained. And allocation of the sample sizes, it is a proportional allocation and optimal allocation I discussed. The proportional allocations means it is a ratios must be the equal sizes and the optimal allocations is here we will divide into the parts of that. Optimal allocations and Newman optimal allocations, both the types we have. It is a Newman allocations we have that is a small fractions also we should be considered. This is the overall idea. Next, the variants of the stratified random sampling under the optimal allocations also I discussed. And the problem I discussed with the calculation of the Newmans and as well as the proportional allocations. And comparison of the stratified random sampling, it is the most important. It is a variance of the optimal at less than or equal variance of the proportional. It is less than or equal variance of the random sampling. The theorem I explained, proof also I discussed today. Advantages and disadvantages, advantages and demerits also I discussed today. Okay, this is a oral idea, and the next class we will discuss the systematic random sampling. Okay, thank you, Anand.